All right, here's problem 28. What fraction of the first 100 triangular numbers are evenly divisible by 7? Express your answer as a common fraction. And so we first need to figure out what the triangular numbers are. And they can be defined as such, because the triangular numbers are 1, 3, 6, 10. Originally, they're meant to represent like these triangles, kind of like square numbers. But since they're also the sum of like the first and the nth triangular number is the sum of the first n integers, then you know that using that famous formula, that the sum of the first n integers is n times n plus 1 over 2. We know that the nth triangular number is n times n plus 1 over 2. So we need to find n where n is bounded as such, because it's in the first 100 triangular numbers, such that 7 divides n times n plus 1 over 2. So this over 2 is never going to affect it. Like this over 2 is never going to prevent us from being divisible by 7. So instead, this is 7 divides n times n plus 1. But because 7 is prime, this means that we either have that 7 divides by n or 7 divides n plus 1. Because if 7 divides neither n or n plus 1, there's no way to like merge them together. Because like with 6, you can, if like 6 divides n times n plus 1, you can have 2 divides 1 and 3 divides the other and then like combine. Whereas with 7, you just have to have all of the 7 in one of the factors. So we must either have that n divides 7 or 7 divides n plus 1. And so we can just find the values now. So it's 6, 7, 13, 14, 20, 21, all the way up to 98, 97, 98. This is 7 times 14. And so since this is 7 times 14, there's 14 rows, and therefore there's a total of 28 such triangular numbers. And then now we just find the probability, which is 28 over 100, which equals 7 over 25.